First of all, go to your notebook. Before going to notebook, there you have the option of extensions in VS Code. Just search for Jupyter Notebook and just install this Jupyter Notebook extension. Okay. Once you installed it, come back to your project directory. Inside notebook, create a file, name it anything like notebook.ipynb. That is the extension for Jupyter Notebook, ipynb. Okay, just press enter. Your notebook gets created. For easy Jupyter Notebook testing, what we're gonna do is just copy this train.csv, just copy and paste it in the notebook folder. You get your train.csv inside the notebook directory. Come back again to notebook.ipynb file. Now just create a code cell and just run it. For running, press shift and enter at the same time. Just press it. You will get the option of Python environment. Select Python environment. Select your current virtual environment. That will be under the recommended. Okay. Just click on it. Now again run the cell. It is connecting to the. Now it will ask for installing the ipynb kernel. Just install it. It will take some time, approx 2 minutes, to install your ipynb kernel so that you can implement your Jupyter Notebook codes. Okay, just wait for some time. Once it's installed, we will start writing our Jupyter Notebook code. Once your kernel gets installed, just run the first cell. It will get executed. No error message, anything. So it means your Jupyter kernel is successfully installed. Now start writing your Jupyter code. First of all, we will do some basic import. So import pandas as pd, import numpy as np, import matplotlib dot pyplot as plt for visualization purposes, import cborn as sns. But there you get a yellow line. Why? Because matplotlib and cborn are not yet installed. So just install them. Just write exclamation mark pip install matplotlib and write cborn. Just execute this. It will install your matplotlib and cborn. So as you can see, your matplotlib and cborn gets installed. So you can remove this code now and just run the first cell again. And your imports are done. You get a green tick here, right? Now, after importing these library, what we will do is import warning. Import warning module. Why we are importing? Let me write the code first. Import warnings. Warnings dot simple filter ignore. Just run this. Now, what is the use of this block of code? Basically, when you work with Jupyter notebooks, many times you get a warning messages. So we are simply ignoring those messages. You might have seen while working on Jupyter notebook yourself also. Okay, so we will be ignoring those warning messages so that they don't show on our output console, right? Now just read your data. For reading the data, df equal to pd dot read csv, and it is train.csv, train.csv, and just print df dot head. Okay, we are getting our data frame. Now let's talk about our columns. First one is a name 0, that is unnecessary column, which is generally created due to the extraction from GCP. Okay, leave it. Second, we have booking ID. Whenever you book a hotel room, you get a booking ID basically. So that is what only. Then we have number of adults and number of children. Like in the reservation, how many adults are there and how many children are there. Like in here, we have number of adults 2, number of children 1. So basically it can be a family where there is a father and mother, which comes under the adult category, and they might have a son, which comes under the number of children category. Okay. Then we have number of weekends night, number of weeknights. Weekends are basically what? Saturday and Sunday. So basically hotel prices are higher during weekends and lower during weeks. So that might influence our price. Like if a person is staying 2 weekend nights, he might have a higher booking price as compared to the person who is booking for 2 weeknights, right? Then we have type of meal plan. So there are basically meals like dinner, lunch. Okay, so there can be meal plan, like there can be a basic meal plan, intermediate meal plan, a luxury meal plan. So this is like this only. Like in basic meal plan, you will have only simple food. In luxury meal plan, you will have exquisite meals. Then required car parking space. Like, does a person require parking space or not? Like if he come to hotel from a his personal vehicle, of course he will require parking space. But if he had come by some public transport or from a taxi, then he don't require any parking space, right? So 0 indicates no parking space required, and 1 indicates parking space required. Then we have room type reserved. Which type of room has the person reserved for himself? Like there can be various room, like basic room, then we have deluxe rooms. Okay, like this. Then next we have lead time. What is lead time? It is a difference of days between the reservation date to the arrival date. Like the difference in days when the person has booked the hotel and when the person actually came to the hotel. Okay, that is lead time. Next we have arrival year, arrival month and arrival date. These three columns basically signify at which time this person came to the hotel, the year, the month, the date. Okay. Then we have market segment type. It is basically defining how the hotel room was booked, online, offline, or any other market segment type. Right. Then we have repeated guest. It will be 0 if the person is not a repeated guest. It will be 1 if the person is a repeated guest. Then we have number of previous cancellation, whether this person has cancelled a hotel reservation before this current booking. Then we have number of previous bookings not cancelled. It is just the opposite of previous one. Then we have average price per room. This one basically signifies the average price that was running at the time of booking of the rooms in that hotel. Okay. This is basically in euros. Euros is the currency. Okay. Then we have number of special requests. What are these number of special requests? Basically, when you book a hotel, some people request like we want this floor, we want a high floor, we want a low floor, we want this type of view from our balcony and all. So these are number of special requests. Then we have booking status. That's our main target column, whether the booking was cancelled or not cancelled. Okay. So I think you had understood all the columns that are in our data set. Let's check all our columns using df.columns. So here are our all the columns. First of all, we are going to remove this unnamed 0. We don't need this. This is an unnecessary column. So we will be going to do df dot remove df dot drop column, sorry. df dot drop columns equal to, let's put the name unnamed 0. We are also dropping booking ID also. Why dropping booking ID? Because these two are unnecessary. Why unnecessary? Because booking ID is unique to every customer. Every customer has a unique booking ID. So it does not benefit us much in a model making. So we are dropping them. Then in place equal to true. Let's check our data frame now. Okay. So we have dropped the two columns. Check our shape of the data frame. So we have around 29,020 rows and 18 columns. Okay. Now let's check for null values. df dot is null dot sum. So we don't have any null values in our data frame. That's good. Let's check for duplicate value. For that, we will use df dot duplicated dot sum. Okay, so we have around 7,661 duplicate values. We can fix these duplicate values, but for instant, we are going to drop these duplicate value. So we will be doing df dot drop duplicates and just place in place equal to true so that you make permanent changes. Now let's df dot duplicate dot sum again. Now you have 0 duplicate values. Let's check the shape df dot shape. Okay, so now number of rows has been reduced greatly, 29,000 to 21,000. Well, that's not a problem. It's good enough. 20,000 rows are good enough for a machine learning project. Okay, now we will be examining our columns one by one. So let's df dot columns again. Let's check our columns one by one. First of all, number of adults. Number of adults. So dot value counts. So majority of people who are booking generally have two adults in their reservation. Then we have one adults in the reservation, and in very rare cases we have four adults in the reservation. Good. Then number of, let's check number of children. Okay, so most of the hotel bookings are with no children, like zero children are there. So basically the hotel is doing couple booking mainly. Okay, family bookings are less as compared to couple booking. We get this much insight about the hotel bookings, right? Then we have number of weekend nights. Let's check number of weekend nights. Okay, paste. Okay, so most of the people are not remaining at the hotel during weekend nights, because of course the price is very high during the weekend nights. So most people don't prefer to stay at weekend nights, but there are majority of people also who are remaining for one or two weekend nights. Okay, then we have number of weeknights. Let's check this also. Number of weeknights. So most of the people are remaining for 2 weeknights or 1 weeknights or 3 weeknights also. That's good. Now we are checking for type of meal plan. How many meal plan do we have? Just paste it here. We have basically one, two, three. Three meal plans are there. Most of the people are opting for meal plan one, and most of the people have not selected meal plan. Maybe they will select at the hotel only. They have not specified at their reservation. Okay, they will order at the when they arrive at the hotel. They will order then only. Then required car parking space. Let's check this. Okay, so most of the people have not opted for car space. Why? Because basically when you go to a hotel reservation, and basically we know this hotel data set, there are mainly couples. So they don't go by their personal car. Basically they are on for a vacation and all. So they generally come by public transport, cab service and all. Very less people come to hotel by their personal vehicle. Then we have room type reserved. Let's check this also. How many types of room we have? So basically we have 1 to 7, 7 types of room, and basically mainly people are opting for room type 1. Okay, because mainly two people are coming at the hotel, number of adults two, or basically a small family is coming, so they don't require much bigger room. Room type 1 is basically denoting a small room with one room and one bathroom and all, so that's enough for a couple or a small family. Then we have lead time, that will be different for different person. Arrival year, Let's check this. Let's check arrival year. Okay. So basically the hotel reservations are from 2018, right? Then we have arrival month. Then we have arrival month. Okay. So basically people are coming at the winter time because 10, 11, 12, 8, 9, like then we have starting months 1, 2, 3. We have very less bookings. But in the ending months, that is winter season, 10, 11, 12, we have higher bookings. So that denotes that hotel is busy during winter months, right? Then we have market segment type. Let's check market segment type. Okay. So mainly hotel reservations are done online, some are done offline, some are corporate, some are complimentary, and very less are aviation based. Mainly hotel reservation are done through online. Now we have number of previous cancellations or repeated guest. Let's check the repeated guest. Okay, so mostly there are new guests only. Very less people are the repeated guest. That's good. Then we have number of previous cancellations. Let's check this. Okay, so mostly people have not done any cancellations, but some people have done 11 cancellations. So basically they are fraud type of people. Okay, but it's good news, like mostly people have not done any cancellation, so like they are genuine customers for the hotel. Then these are not important. We will go with the booking status because average price per room is a numerical column. We will go with booking status. Okay, so here you can see our data is quite imbalanced. Like we have many rows for not cancelled, but we have very less rows for cancelled. But we will fix the data imbalance with our data processing techniques, so don't worry about that. But here we get an insight that our data is quite imbalanced, so let's note it down. Our data is imbalanced. Escape M, and it will. Now let's write the code. Let's specify our category column, and let's specify our numerical columns in different variables. Cat calls. Okay, let's specify our categorical columns. What are our categorical columns? So basically, number of adults, children, these are numerical. Number of weekend nights, these are numerical. We have type of meal plan, that is our categorical column. That is our categorical column. Then we have required car parking space. Okay. Room type reserve, also a categorical column. Just copy these two and paste it here. Then we have market segment type is also our categorical column. Then we have repeated guest. This is also our categorical column. Then lastly, these are all numerical. We have booking status as our categorical column because there are basically categories there. Then we have numerical columns, num calls. Except these, just copy all the number of adults, number of children, number of weekend nights, number of weeknights. Copy and just paste it here. Now you have required car parking, room type, lead time, arrival year, arrival month, arrival date. These are also our numerical columns. Paste it here. Okay. Then we have number of previous cancellations, number of previous booking not cancelled, average price per room, number of special request. This can also be a numerical column. Let's check if we are not missing any column. Length of cat calls. It's 6. Length of num calls. It's 12. 12, 6, 18. Okay, fine. We have specified all the columns now. Okay. Now what we will be doing is our data analysis. Okay, EDA and all. So for this, we will create a copy of our data frame. Data equal to df dot copy, so that our main data frame don't get affected. So let me check whether it's perfectly copied or not. Data dot head. Yeah, it's perfectly copied. Now, first of all, we will do univariate analysis, like using a single column. Okay, good. Now, first of all, we will be doing univariate analysis of numerical columns, all the numerical columns. What we will be doing is we will be plotting histogram as well as box plot of all the numerical columns, and our all the numerical columns are stored in num calls, right? So let's just do univariate analysis. For this, we will be creating a function that is num plot distribution. Let's call it dist. Here we will pass the data frame and pass the number of columns, num features. Okay, let's come under this. Let me write the code first. Fig access plt dot subplots. There is a typing error. Plt dot subplots. Then we have length num features. We want to show two graphs in one row. Then fig size will be equal to, I'm giving it 15 because we want a little big, and width will be length equal to number of features into 5. Okay, you can specify it manually also, 15 into 15, but I am doing in this way. Okay, now here we created the overall structure for our graphical representation. Now we start creating graph. If length of num features is equal to 1, then axis equal to axis, right? Now we start creating our graphs for I comma column in enumerate. We will be looping into our number of features which we specified here. We will be enumerating in them. Then we will create histogram sns dot hist plot data equal to df, which we will be specifying here, right here. Then x equal to column. On our x-axis will be the column. On our ax-axis will be having axis I1. Right? I think I1 or 0. Okay, 0. Then we want KDE, kernel density estimation. Yes, we want the kernel density estimation. Then you can select any palette. My favorite is blues, so I will go with the blues. Right? So here we are creating histogram plot of all the numerical columns. Then we will set title for each graph. For this, you will use access I0 dot set title, and we will write histogram for this column, like whatever the column name is, right? So here we will create our histogram. Now coming to box plot. Now we will create box plot for each column also. So sns dot box plot data equal to df, right? And x equal to column, right? And then same ax equal to axis I, but this time this will be 1. What is this 0 and 1? I will tell you as soon as we print the graph. Then select palette equal to, okay, I press enter by mistake, blues, right? Then just set the title here also, access I1 dot set title, and we will write here f box plot for certain column, whatever our column is, right? And just set here plt dot tight layout so that it properly get displayed, and just plt dot show. Just run this, successfully get run. Another code cell. Here we will write, here we will execute our function now. What is the function name? Num plot dist. Num plot dist. First parameter is dataset. Our dataset name is data now. We have created the copy of the df, and number of features are stored in num calls. Just press enter. It will start generating your graphs. Just wait for some time. Okay, we get the graph. First of all, we are getting for number of adults. Here we are getting histogram, then we are getting box plot side by side. Histogram for number of adults, histogram for, sorry, box plot for number of adults. Histogram for number of children, box plot for number of children. So how the code is working is, like I was telling you know, what is 0 and what is 1. This is 0. The first graph is 0. It is defining column. It's the 0th column, and this is the first column. So we are specifying, like, on 0th column all the hist plot are shown, and on the first column, that is the right one, all the box plot are shown. So you will see all the histogram are on the left side. That is the 0th column. Column is vertical, and on the right side we get all the box plots. You will see all the box plot here. Okay, so this is how we will plotting our numerical columns. Now let's talk about some insights from the graphs. First of all, number of adults. As we have already discussed, mostly number of adults are 2. So it indicates that uh, mostly couples are traveling. Okay. Then we have number of children. Number of children is basically 0 in most cases. So that means the hotel reservation are mainly focused on couple bookings. There are very less cases where there is 1 children or 2 children. Like there are family booking also, but as compared to couple bookings, family bookings are very less. Then we have number of weekend nights. Okay, so mostly people are remaining for 0 weekend nights, because at weekends the price generally go higher in hotel reservations. So mostly people prefer to stay for only 1 weekend night, or mainly they focus on weeknights because they are less expensive. But there are some people who have stayed for 6 weekend nights. So these are considered as outlier, because very less people are there who will stay for 6 weekend nights. 6 weekend nights mean 3 weeks stay in a hotel. That's very expensive. Not everyone can afford, right? Then we have weeknights. Weeknights is okay, good, because people can stay for 1 week also. That's not a problem. Then we have lead time. So we can see our lead time column is skewed. It's skewed data, not normalized data, it's skewed. And there are various outliers also in the lead time. There are various because see, some people are taking 400 days. 400 days means more than a year. Like they are booking a hotel a year before their actual arrival date. That's not possible generally. Why you will book a hotel 1 year before? That's generally outlier only, right? Then we have arrival year. So you can see mostly booking are done in 2018 and some are done in 2017. Then we have arrival month. So you can see in starting of the year, we get very less booking. In spring season, that is March, April, we get a little boost. Then there is a drop down. And at the end of the year, that is October, November, and December, we again get a spike. But mainly we get spike during 8th month, 9th month, and 10th month. These are the highest selling season. That is basically our autumn season. Okay. And there are no outliers in this. Then we have arrival date. Arrival date is pretty much normalized only. Like uh, it's evenly distributed. Like at the starting of the month, there is a spike. At the middle of the month, there is a spike. At the end of the month, there is spike. Rest there is even. Then we have number of previous cancellation. So mostly people have not cancelled. They are first time registering and they have not done any previous cancellations. That is just this column is just the opposite of number of previous cancellation. This is number of previous booking not cancelled. Okay, this is just the opposite. So then we have histogram of average price per room. This column is a bit normalized. It follows a normal distribution a little bit, but there are outlier also, because sometimes a hotel room has average price of more than 350 euros, which is generally considered a outlier only. But basically the price range from mainly the price ranging from is 75 to around 130. Okay, if you focus in on this graph, it's around 75 here and 135. Mainly it ranges from 75 euros to 135 euros. Then we have number of special requests. Mostly people don't give any special request. Some people give only one special request, but there are some people who are giving 5 special requests. Like they want high floor, they want this view from balcony, they want this and this and this. Okay, they want everything according to them. So this is pretty much your all the numerical columns and their insights. Next we will be doing univariate analysis of categorical columns. For categorical columns, we will create another function. Let's create another function. But instead of creating any function, we just loop. Okay, we will do looping for cat feature in cat columns. We will loop in the cat columns and then plt dot figure figure, just specify the fig size equal to 10,6. I think is a pretty good size. Then we have data, where our data is stored, just cat feature dot value counts dot plot. We will plot directly from the value counts section and just specify the kind of plot you want. I'm specifying I want bar plot, right? And just specify the color. I will go with sky blue color. It's optional. Then title, plt dot title. So title will be f string, whichever our cat feature is there. Cat feature. Just write distribution. Distribution. Then specify x label. X label. On x label we want cat feature, whatever the name. On y label, plt dot y label, we want to show count. Then show plt dot show. Just press enter. You will get all the categorical columns graphs. They're bar graphs mainly. First of all, we have meal type of meal distribution. So we have already discussed that mostly people are opting for meal plan 1. So what could be the reason for opting for meal plan 1? Basically, it can be a reason that uh, this is basically cheaper than all other meals, and basically couples and small families will opt for this only, right? And people who have not selected, because they are booking the hotel, once they arrive at the hotel, they will order for themselves at the site only. They are not predefining like we want this and this. Most people do this only. Then we have required car parking space. Mostly people don't require car parking space. We have already discussed the reason. Then we have room type reserved. Basically, people are opting for room type 1 because basically it will be cheaper, it will be smaller. And basically, we found out that mainly couples and small families are there. So they don't need a big room, a deluxe room. They are happily content with a small room. Then we have market segment type. Basically, hotel reservation have a higher online market as compared to others. Offline, corporate parties, complimentary, aviation. Corporate means maybe hotel reservation is done for a corporate meeting or anything like that. Then we have repeated guests. Mostly people are new. Some are there who are repeating a hotel reservation at a particular hotel, but mostly there are new people. Then we have booking status, where we get to know that our data is highly imbalanced. We have pretty much good records for not cancellation data, but we have very less record for cancellation data. So there might be a imbalancing issue during model training. So we have to fix this imbalancing issue. Okay. So keep it in mind. We will fix it. Don't worry. Now our univariate analysis is done. Now what we're gonna do is bivariate analysis. Like this time we will be using two columns for analysis. First we will go with numerical to numerical bivariate analysis. Like we will compare two numerical columns against each other. So let's just create a function plot bivariate for numerical. ठीक है? Okay. Then we call df. Then we call the target column against which we want to see our results. Then all the numerical features. So first of all, we will specify our num plots, that is equal to length of number of feature, then number of rows, that is equal to num plots plus 1, and we will just do a floor division by 2. Okay. Now just specify fig and axis and plt dot subplots number of rows. Then we want two columns. Number of rows will be according to this, what we created here. And okay, and number of columns will be two, like left column and one will be right column. Then specify the fig size. Fig size, you can basically 15 comma what we did above, that is num rows into 5. It will be 15, I think 14 is a good. Now just flatten the axis. Axis dot flatten axis equal to axis dot flatten. Now for I comma column in enumerate, we will be looping into our numerical feature, num features. Then just plot their box plot, because box plot is easy to read as compared to other graphs for bivariate analysis. Just do box plot, and x equal to your target and y equal to your column. On x-axis there will be your target column, on y-axis there will be your uh, the column that you are specifying. Then we have access equal to access I. Then specify the data. Data I will be equal to df, which we specified here. Then you have palette. Palette equal to, I will go with blues again. You can select anything according to yourself. Then we will set access I dot set title f column column versus the target. Then plt dot tight layout and plt dot show. Just run this. Now use this plot bivariate num, specify your data, that is data. Then specify your target column. Our target column is gonna be booking status. So booking status, and your input columns will be num false. Okay, just run it. It will take some time. Okay, all your graph are generated. First, we have number of adults versus booking status. Okay, so that's good. Like we don't have any influence of number of adults on the booking status. It is approximately same. Number of cancel and cancelled. Number of children also don't have that much influence. These are all same. Now, number of weekend nights, it also don't have that much influence. It's good. Number of weeknights, it also don't have that much influence. Then we have lead time. Look here. In lead time, okay, graph is not getting big. Look, this is your lead time. Okay. So here, not cancelled is when the time limit is between 0 to it's around 80. When the lead time is around 80 days, generally bookings are not cancelled. Okay. When lead time is around this much. But as soon as lead time increases, lead time is around 200, 100 plus, cancellation chances grow bigger. That is what this graph is specifying. Because cancellation, look, this center line is known as the mean line. This is above as compared to the non-cancelled mean line. So it indicates that as soon as lead time increases, cancellation chances also increases, right? Then we have arrival year. Arrival year have not any influence. Arrival month also don't have this much influence. Arrival date also don't have this much influence. Number of previous booking also don't have this much influence. Then we have these columns don't have this much influence. Uh, Lead time was the major factor that I want to tell you here. So there is one more thing I want to show you here is the graph between arrival month and average price per room. Why? I will tell you. SNS dot bar plot. Let's first complete the code. X equal to, on x axis we will show our uh, arrival month. On y axis we will show our average price per room, and the data will be data equal to data. Okay, then plt dot show. So this is your graph. On x-axis you have months 1 to 12, January to December, and there is the average price that was currently ongoing uh, at this current month. Now, why I have plotted this graph? Because if you go back to your uh, if you go back to your this graph, arrival month graph, here this is the persons count. Okay, here this is the persons count, like this much persons were coming in this month, right? See this graph and see this graph. This is of price, but both graphs are similar. Why? Because hotels are smart. because in with this month you are getting this much customer, so they increase the price of each room. In this month you are getting less customer, so they decrease the price of the room. So this is how hotels strategically work. So this is the insight I was aiming for with this code. Okay, now we have plotted bivariate analysis of numerical feature. Now let's plot the bivariate analysis of categorical feature. Let's create a function plot bivariate of categorical CAT. First we will pass our data frame, then pass our target column, that is our booking, then pass our cat features. Okay, come inside this. Then we have cat features equal to length. Okay, number of features. Number of features equal to length of cat features. Like how many categorical features we have, cat features. Then we have number of rows, like we did above now. We are doing same thing only. Number of rows equal to number of features plus 1 floor division by 2. Got it? Now again fig, again access, then we will do plt dot subplots. Same thing we have done above. Same thing, exactly same. Okay, exactly same. So you can just copy also. If you want to copy this much, you can just copy and just paste it here. Just paste it here. Right? Now for I comma feature in enumerate. Now what we will be enumerating, it will be cat features this time. Previously we enumerated numerical features. This time cat features. And for categorical, we will be plotting what? Count plot. So SNS dot count plot. This is a very famous graph for plotting categorical features. So x equal to, on x axis we will have our feature, and on u we will have our target. Okay, then we will have our data, because count plot is basically used for univariate analysis. To make count plot available for bivariate also, we use the parameter u. Data will be equal to df. Then we have palette. uh, palette we will be using this time is set to, and this is basically orange and green palette. And then we have access equal to, sorry, ax equal to access, and we have I. Then coming to the next line, just set the title, label, x label, y label. So setting x I dot set title. What you will give the title? Just pass feature versus target. Okay, you can give the x label, y label also, but I am not giving x label, y label. I want to rotate the what you will say, the what you will say to this, I think tick params, we will rotate them vertically. Why? Because it can collide with each other. Axis I dot tick params axis equal to x, and rotation equal to 90-degree. You will rotate it vertically. Then we have plt dot tight layout and plt dot show. Okay, just then you will use this function plot bivariate cat. First pass your data, then pass your target column, that is your booking status, booking status, and then pass your categorical columns, that is cat calls. Just run this. Okay, this is your set 2, that is green and orange. And by rotation I mean this, basically these are horizontal, but we have rotated them 90 degree, so now they are vertical. Because if they were horizontal, they might collide with each other. There are pretty good chances they might collide with each other, so we have made them vertical, and that is looking good also, right? Now let's talk about some insights. First of all, this is type of meal plan versus booking status. Green denotes not cancelled, orange denotes cancelled. So talk about meal number 1. When a person is opting for meal number 1, when a person is opting for meal number 1, there are chances a person can cancel the booking. Okay, but when a person is opting for meal number 2, there are very high chances that person can cancel the booking, because if a person is opting for meal number 2, majority of times he is canceling. Like if 10 persons are booking, 10 persons are not canceling, 7% are canceling also. So there are high chances if a person is booking for meal number 2, he might cancel your reservation. Okay, then we have required parking space. If a person is not opting for car parking space, there are chances he might cancel your reservation. But if a person is opting for car parking space, there are very slim chance, almost negligible, that he will cancel your reservation. Then we will go with room type reserved. There are same only, like when a person is booking room type 1, there are chances he can cancel your reservation. Same goes with room type 4 also. Same goes with room type 2 also. Same with room type 6. And room type 6 have higher chances that the booking will get cancelled. And hotel will suffer a huge loss, because room type number 6 are generally deluxe rooms. So if they get cancelled, hotel will suffer losses, obviously. Then we have market segment type. If a corporate is booking for hotel reservation, there are very slim chances that the reservation will get cancelled. But if it is done through online, there are 50% chances that it can get cancelled. Same with repeated guest. If the person is not a repeated guest, like 0, so there are chances he can cancel. But if a person is a repeated guest, there are no chances that he will cancel, because he is a repeated customer. He has previously booked also. So there are very slim chances that he will cancel. Slim, I will say negligible, because there is no orange line here. Then we have booking status versus booking status. That is not a graph. Okay, ignore this last graph. Booking status is compared to booking status itself. So you will get the booking status only, right? Then this is the visualization part. We have done the data analysis, and I hope you have got all the insights also. Like when repeated guest is like this, cancellation chances are like this. When this is this, when this is that, this is this, this is that, chances are this, chances are that. Okay, you got it, my right. Now all of your data visualization, all of your data visualization is done. Now moving on to data processing. Let's talk about data processing now. First of all, create a code cell. First we're gonna do is, let's check our df.head. Now we are working with df.head. Okay, data, we created a copy for visualization purposes, so that it don't affect our main data. And our main data is here, df.head. Let's check this. Now what you will see here is, let's check the df.info. Look, some columns are object, 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 object. 4 columns are object. We can't pass object data type columns to a machine learning model. So we have to convert them. We have to convert them. Like this is type of meal plan. So we have around 6 to 7 meal type plans, I think. or think we have 6 to 7 type of room reserved. Oh, I have I forgot. Meal plan are 4 in number, room type reserve are 6 in number, right? Then we have market segment type. This is also object data type. And then we have booking status also. This is a object data type. We have to convert these 4 columns to a non-object type, basically integer, right? So we have to do what? Encoding. So basically we have various type of encoding. We have ordinal encoding, we have one hot encoding, we have label encoding. We will go with label encoding, right? So let's do label encoding. For label encoding, let's write here label encoding. For label encoding, first we will do some imports. Our imports are from sklearn dot pre dot pre processing import label encoder. Just run this. Import successful. Now let's initialize our label encoder object. Label encoder. This is our variable. Inside this variable, let's initialize our label encoder. So here we will initialize our label encoder. Then we will do mappings storing. We will store our mapping so that we at the end we know which label was marked at which number. Like suppose uh, let's check this. We have booking status. We have two type of booking status, not cancelled and cancelled. First, we will take the scenario where we are not doing mapping. Okay, so we just label encode them and we are using label encoder. It will encode, but you don't know. Suppose it encoded as 0 and 1, but you don't know 0 is marked for what? 0 is marked for not cancelled or 0 is marked for cancelled. Okay, so mapping is important. And here there are only two categories, cancelled and not cancelled. But in room type, you have 6, 7 category. How we will get to know which room type is marked by which number? So to know this, we need the mappings, and we will store those mappings in this dictionary. So I am creating a empty dictionary here with the name mappings, right? So let's iterate over the columns and do label encoding. For column in category columns, we are iterating over all the categorical columns. For df call equal to label encoder dot fit transform df call. It will perform the label encoding on the column. Like all the columns in the cat columns list will get label encoded. Now we have to store the mappings also. For storing, what you will do is mappings, that is our empty dictionary, with the specific number, or we can say specific column, mappings column equal to, how you will store label label code for label code in zip label encoder dot classes underscore now comma label encoder dot transform label encoder dot classes. So I hope this much is clear. This code is going to store the all the mappings inside your mappings dictionary. So this is the code, mappings call label colon code for label code in zip label encoder dot classes label encoder dot transform label encoder dot classes. Okay, now this much is done. Let's run this. Successfully run. Then you want to see your mappings also now. For, for this, use a looping statement for label comma code in mappings dot items loop here, you will loop into the mappings dictionary. You can also wait, you can just print the mappings dictionary also. Mappings, look, yeah, you don't need to write this much code. Just type of meal plan 1 is indicated by 0, meal plan 2 is indicated by 1, meal plan 3 is indicated by 2, not selected is indicated by 3. Same goes with room types, same goes with market segment type. Aviation is indicated by 0. Now check your df dot head. Look, all your columns are now encoded. Let's check df dot info also. Look, all here are integer. One is float, that is average price, so it will remain in float. Rest all are integers. So it means now we don't have any object data type, and our all the columns are suitable for a model training process. But before moving on to the model training, we need to check whether there is multi-collinearity in our data. What is multi-collinearity is, first of all, let me write here multi-collinearity. It basically tells us whether our one column in dataset is highly related to another column in the dataset. We have two types of feature. One are input feature, one is target feature. If the input features are correlated with each other, we call it multi-collinearity. And multi-collinearity negatively affects our machine learning model. So we have to avoid multi-collinearity. So first of all, we will check whether there is multi-collinearity in our data or not. For this, we will need a library. So this library is pip install stats models. Just install this library. Wait till it get installed. As you can see, our stats model library is perfectly installed. Now just do some imports. Our imports are from stats models dot stats dot outlier influence import variance inflation factor. In short, we call it VIF. It detects whether there is multi-collinearity or not. Then from stats models dot tools dot tools import add constant. These two imports are needed. Now let's check. First of all, x equal to add constant, and we will add the constant to all of our data frame, right? Then we will create and we will create a data frame, and we will calculate the VIF factor for each of the feature. For this, first of all, we will create a VIF data, a empty data frame. So pd dot data frame, created a empty data frame. Now VIF data feature, let's create a column name VIF data feature. We created a column named feature. Then x dot columns. What this VIF data feature column will have, it will have all the columns name. Let me show you. VIF data, look, it has all the feature names, number of adult, number of children, number of weekend night. You can ignore this constant, it is nothing. Okay, you don't have anything to do with this constant. Just look from here, number of adults, right? Now what you will do here is, now we have to calculate VIF, variation influence inflation factor, for each of the feature. For this VIF data, I am creating another column VIF equal to, we will do a list comprehension variance inflation factor on x dot values comma I, right? For I in range x dot shape 1. Let's run it. it successfully gets run, and you will get your VIF of all the columns, number of adult 1.34, 1.28. You will be happy to know that our data set don't have any multicollinearity. Why? If the number is above 5 or 6, 7, 8, something like this, then we will say there is multicollinearity. If the number is above 10, we will say it's very high multicollinearity. But if the number is small, like 1, 2, so very less multicollinearity, almost negligible. So we will mark it as that our data don't have any multicollinearity, which is a good news, right? So our data don't have any multicollinearity, right? Let's make a correlation matrix for our data set. For this, for equal to df dot core function. You can check core, but this is very hectic to read. So we will create a heat map of this. So sns dot heat map, and you will use core, and you can use n not equal to true. So you will get the these values also mark on the heat map. Just run it, but this is looking very bad, right? So we will do is create a plt dot figure and give the fig size. Fig size we will be basically giving 10,8. I think it's good. Still there is a overlapping. Let's fix this with line width 0.5. Will it fix? Still not good. Let's make it 10 on 10. Mm, let's remove this anode dot true. This is making the issue. Okay, so we get our heat map. So basically we will check with our booking status uh, which columns are highly correlated or negatively correlated. So here you will see the color coding. Like when the color gets lighter, color gets orange or lighter, it means positively correlated. When the colors get blacker, it means negatively correlated. And when it is neutral, it is around reddish. So let's see. For booking status, with number of adults, it's around minus 0.2 or something. A little bit negatively correlated, almost neutral. It's almost neutral. It's almost neutral. With lead time, it's negatively correlated because as soon as lead time increases, cancellation chances also increases. So they are negatively related because as the lead time increase, booking chances get decreased, right? Then we have this column is only greatly related. Rest all are very slightly or neutral related. So good, that's good. So this is our correlation matrix. Now we should check the skewness because during visualization we found that some of our columns are skewed. So let's check for skewness. So checking skewness equal to df dot skew, and let's print our skewness. I think typing mistake. So look at here. This is good. This is a little bit positively skewed. This is good. This is good. But look, number of previous cancellation, they are highly positively skewed. Number of previous booking not cancelled, they are also highly positively skewed, right? So we have to fix these type of columns. For this, what you will do is you will do log transformation. You can apply any technique for skewness handling. I am using log transformation. What you will do here is just iterate over the columns for column in df dot columns, right? And if skewness of the column is greater than 5, if the skewness is greater than 5, what you will do is df column equal to np dot log 1p. We are doing log transformation. We will apply log transformation on that certain column. Applied. Let's again check our skewness now. Let's again check our skewness now. Run this command again. Look, it was around 22, it is reduced to 13. It was around 15, I think, it is reduced to 7. And others are also influenced a little bit. So we have little bit fixed our skewness also. So that's good also. We have fixed our skewness too. Now, the most important. From the data visualization, we get an insight that our data is highly imbalanced. So now we are going to handle that imbalanced data. Let's check our data. df booking status dot value counts. Look, uh, when booking status is 1, booking status is 1. What does this booking status 1 signify? I think we have encoded them. So booking status, what is booking status now? 1 signifies not cancelled. Okay, 1 signifies not cancelled. So we have 15,000 records of not cancelled data, but we have only 6,000 records of cancelled data when the reservation was cancelled. That is a very high imbalance, almost more than 2 times. So we have to fix this. Uh, First we can do is undersampling, but undersampling is very risky in our case because we have almost 20,000 rows only, and if we do undersampling, that 20,000 will get reduced to 12,000. So we can't do undersampling here because our data will get more and more less. So we will be doing oversampling. With oversampling, we will get around 15 and 15, 30,000 data. So we will get more data as well as our imbalanced data condition will also get fixed. For this, let's split our data. For this, let's split our data into X and Y. That is our input columns and our target columns. X equal to df dot drop columns equal to booking status. Okay, and Y equal to df booking status. So let's check our x dot columns. So here we will have all the input columns and y dot columns. Okay, y only have one column only. So y is not a row. So x we have all the input columns, and here you will see uh, we don't have booking status because booking status is inside this y, right? Now you have to install a library, that is pip install imbalanced learn. Just install it because there is a technique named SMOT, SMOTE, which is inside this library. Once this library is installed, let's check our class distribution before SMOT. So y dot value counts. This is our value counts distribution now before the SMOT technique. Now we are applying the SMOT technique. For SMOT technique applying from learn imbalance learn dot oversampling import SMOT, right? Just import this. Once this is successful, just write SMOT equal to SMOT. We are initializing our SMOT and give it a random state equal to 42, or you can give anything 0, 5, 7 initialized. Then X res and Y res. X residual, Y residual. Smart dot fit resample. We are going to resample our data. Smart dot fit resample. On which you will be going to do resampling? On our X, that is our input column, and on our Y, that is our output column. X resampling will get stored in XRES, Y resampling will get stored in YRES. Let's run this. Run. Now check our YRES value counts. For this, we will convert it into series first, because we can't directly see value counts without converting into series or data frame. So convert this into, because currently it is in a numpy format. You can see Y res. I think it is in the data frame format only. Let's check Y res dot value counts. Okay, huh? It is on the uh, series format only. I thought it is on numpy format, but it is previously in the series format. And you can see now you have 15,231 for 1, 15,231 for 0 category also. This was your before smart 15,000 and 6,000. Now this is your after smart 15,000 and 15,000. So you get more data, and your imbalanced data problem also gets fixed. Now we have to create a new data frame, because if you see, you will see df dot head, or you will call it df dot shape. You will see now also there are only 21,000, but if you add these 15,000, 15,000, it's around 30,000. So we didn't changed it into our main data frame. So we are going to create our new data frame with these resampled values. For this, create a, so we are creating balanced df equal to pd dot data frame. We will pass xres, and columns name will be x dot columns, right? Then we will add output feature also. Balance df booking status equal to y res. Run it. Let's check our balance df dot head. Okay, we got our balance df dot head. Let's check its shape. Look, it's around 30,462. That's good. This is our new data frame. So we are going to create df equal to balance df dot copy, because we will not write balance df again and again, as df is a little bit easy to write and all. Okay, so that's why I'm making it a copy of balance df. Now you can check your df dot shape also. It will be 30,000, because I have made the df copy of balance df, right? Next we're gonna do is our feature selection. Why feature selection? Let's check our overall columns. Okay, length of df dot columns. We have 18 columns. One is target column, so we have 17 input columns. But we don't want 17 input columns. Like suppose if you are getting an accuracy of 90% with 17 columns, and you are getting same 90% accuracy with 10 columns, why are you adding those 7 extra columns, right? So we will be selecting only top 10 columns for our training purposes. For this, there are various feature selection techniques, but we are gonna go with random forest feature importance technique. For this, first you're gonna do import from sklearn dot ensemble import random forest classifier. Right now, you're gonna do is just split your data. like you split it here, just split your data again, x and y में, and you will split it in x and y, split it, you got your data. X have input column, y have output column. Just initialize your model equal to random forest classifier, just give it a random state equal to 42. Now model dot fit, just train the model, just train the model on your x and y. Let's train it. While it is training, okay, you have trained your model. Now let's check model dot feature importances. You get the model and feature importances. Let's store it in a variable called feature importance. Let's store it here. Then we will create a data frame. You will create a data frame, feature importance df equal to pd dot data frame, and just create a dictionary inside a data frame, and feature equal to x dot columns. You will create a first columns with all the columns name. Then you will create a second column, that is importance, where you will have all the feature importance, right? Just run it, and just run your this feature importance df. So you get the import feature with their importance. Number of adults has 0.001. Let's sort it by importance. Feature importance df dot sort values by importance. On the basis of importance, we will be doing sorting. Then in what manner? Ascending equal to false, because we want the high importance column at top. Okay, so these are your most important columns. First most important column is lead time, then we have number of special requests, then we have average price per room, then arrival month, arrival date, market segment, and these number of previous cancellation, number of previous booking not cancelled, these are very least important. Okay, now we will be selecting only top 10 features. Let's store this inside a variable. So we will creating top features, uh, importance, name it anything, df, top importance feature df. Okay, now what we're gonna do is we will create a new data frame again. We have our df dot columns. Let's check our df dot columns. Here we have, oh wait, length of df dot columns. Here you have 18 columns. Now we will create a data set, new data set with 11 columns, 10 from input that we will select, and one is our output. 10 topmost we will select from this top feature importance df, right? So let's select the top 10 features. So we will select top 10 features. How we will select top 10 features? Equal to features, top features importance df, feature, because it has a feature column, dot head. We want how much? 10, top 10. And what we want? Their values, right? Then top 10 df equal to df top 10 features dot to list. We will convert it into a list. as well as we will add the booking status also, because we want the output column also now. Booking status. Let's run this, and now we will check our top 10 df dot head. Let's check. Yeah, we are getting. Now check the length of top 10 df dot columns. We get 11 columns now. Okay, now I am again making a copy, df equal to top 10 df dot copy, so that I don't have to write top 10 df again and again. We will write only df, right? Now we're gonna start with our model selection. We will train various models and check which model is most effective on our data set. For this, I need to install two libraries, that is pip install. Firstly, we'll write a markdown here. Model selection. Pip install xgboost and light gbm. Because these two are not available directly in scikit-learn, we have to install it separately. Just run them. Wait till they are getting installed. This may take a while because these are a little big as compared to other models. Now let's do some imports. First of all, from sklearn dot model selection import train test split, because we will be splitting our data into training and testing sets. Then from sklearn dot ensemble import random forest classifier. You will use gradient boosting classifier. You will use ada boost classifier. We will be using various classifier and checking which gives us most good accuracy without any hyperparameter tuning. From sklearn dot linear model import logistic regression. From sklearn dot svm support vector machine import svc support vector classifier. Then we have decision tree also. From sklearn dot tree import decision tree classifier, and basically it is a classification problem, so we are listing all the classifiers only. From sklearn dot knife base import gaussian knife base. From sklearn dot neighbors import knn k neighbors classifier. From xgboost that we just installed import xgb classifier. From light gbm import lgbm classifier. Now we have to import metrics also. So from sklearn dot metrics import which metrics we will work on. First, accuracy score, then we have recall score, then we have precision score, then we have f1 score. These four metrics are good. I think we have imported all the main classifiers now. Yeah, just import. All imports done. Now just again split the data into x and y. So we will just copy and just do a little bit of paste. Done. Now just split your data. We will split into x train, x test, y train, y test using train test split on x and y. We will be splitting into four parts: x train, x test, y train, y test. X train and y train will be used for training purpose. X test will be used for predicting purpose, and the prediction from x test will be compared to the y test. Y test is the actual values, and x test will get the predicted values. So these will get compared and we will get our metrics from on the basis of that only. Okay, now we have test size equal to 0.2, like 80% for training and 20% for testing. Then we have random state equal to 42, right? Just run this, our data gets splitted. Now just you have to initialize all your classifiers and initialize all your metrics. So let's start initializing our classifiers. So I'm making a dictionary classifiers equal to, let's start classifying. First of all, random forest. So random forest equal to random forest classifier, and we will give it a random state equal to 42. Just come inside this, then we will give logistic regression, and it will also get a random state of 42. So with each iteration their output don't change. Then we have what we imported. Okay, gradient add a boost, gradient boosting, you can name it anything, but just make sure on the right hand side you mark the same model. Also give it random state equal to 42. Now we have support vector classifier, so SVC, and we will give it a random state of 42. Now then we have decision tree, decision tree classifier, we will give a random state of 42. Then we have KNN, okay, K neighbors classifier, you can initialize it as it is. Then we have knife base, there might be a small mistake, typing mistake, that you can ignore. Okay, I have imported Gaussian knife base, right? Gaussian knife base. Then we have XG boost XGB classifier, and we will pass random state XGB classifier. Why it is not showing random state 42? Okay, now we have, oh, I forgot add a boost classifier, random state equal to 42. And last our LGBM, that is light GBM, gradient boosting machine. So we will give him LGBM classifier and random state 42. So finally we have initialized all our classifier here. Just run it. Now we will initialize our metrics. So I am creating a metrics dictionary now. I will store all the metrics. Oh, first of all, I will store models here. Model here inside this list. Okay. Then I will store all the accuracy, that will accuracy score here. Then I will store all the precision. Let me precision here, right? Then I will store all the recall score here. Then I will store all the F1 score here, right? Just run it. We will train these models. Here are our model initialization. Here is our metric storage, or you can say metrics initialization. Like whatever this model will give metrics, we will store here, 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 according to the metrics. Now just train and evaluate each classifier. What we're gonna do is, for model name in, for model name comma classifier, classifier in classifiers dot items, we are going to iterate over that model's dictionary. We're gonna iterate over this. First of all, we will do is classifier dot fit. There might be a confusion. This classifier is denoting the model. Okay, first of all, this is classifiers. Classifiers is denoting this whole list. Sorry, dictionary. Classifiers is denoting this whole dictionary. Then we have model name and classifier. Model name is denoting this. Okay, and classifier is denoting this. Okay, got it. So we are classifier dot fit. On which we are fitting? We are fitting it on X train and Y train. Then we will make prediction. Classifier dot predict. On whom we will predict? Of course, X test. That's underscore here. And where we will store our prediction? Inside our variable name ypred. Right? Then we have to compare our prediction with the actual values. So for that, we will create variables accuracy score, no, accuracy equal to accuracy score, compare y test, that is our actual values, with our predicted values, that is our ypred. Okay, we will get the error. I basically run it ypred, right? So let's ignore this error for now. Then we want precision. Precision equal to precision score, same y test and y pred. Same you will do with recall equal to recall score y test compared with y pred, actual value comparison with prediction values. Same do with f1 equal to f1 score y test with y pred. Got it? Now what you're gonna do is store the results. Here you have got the results, you have trained, you have got the prediction, you are comparing and getting these four metric: accuracy score, precision score, recall score, f1 score. Now what you're gonna do is you have to store these all the metrics inside this empty dictionary. So for this, what you're gonna do is metrics, that is our empty dictionary here, its key model equal to model dot append. What we will add is model name. Got it? Same we will do with metrics accuracy dot append accuracy. We are appending this accuracy to this accuracy. Now same with metrics uh, precision dot append precision, metrics recall dot append this recall. Same do with f1 score also, metrics f1 score dot append f1, right? Just run it. Wait for it because all these models are getting trained, so it will take some time. So all your models are now trained and all your metrics are stored in this metrics dictionary. But viewing in a dictionary is a bit uh, hectic. So we are going to create it in a data frame format. So just create matrix df equal to pd dot data frame and convert that matrix dictionary into data frame. Just run it, and now you will see the matrix. Just run. Okay, matrix df. Look, this is looking good as compared to the matrix. Directly seeing the dictionary and seeing it in a data frame, their readability is big difference. For random forest, we have accuracy of 89, precision of 89, 88, 89. Logistic regression 77, 80, 72, 76. Good. LGBM we have 86, 85, 88, 86. So our top two models are, or we gonna say top three models are random forest, XGBoost, and light gradient boosting machine. So you have three options. You can select any. We will be going with random forest, right? So let's go with the random forest and train that model. So let's train our random forest model, and you will be doing hyperparameter tuning also here. So for hyperparameter tuning, let's import from sklearn dot model selection import. You can do grid search CV also, but grid search CV takes a lot of time. So we will be doing randomized search CV. Randomized search CV from scipy dot stats import random integer. Why this is needed? Because we will be passing parameters like this. We will tell model we are giving you from this range to this range. You will pick randomly from this range and train our model and check which parameters are good. Okay, so let's import these. Again do the splitting. Again do the data splitting. Just copy it from here. Now just paste it, run it. Again do the train test split. I'm not writing again and again. I'm a bit lazy. Just copy it again and paste it here. Okay, once done, let's initialize our random forest model. Rf equal to random forest classifier and random state equal to 42. Initialize your model. Let's now define our parameters list. So params distribution. So what are our parameters? If you have learned about random forest classifier, you have various parameters. Like one of them is n estimators, right? Then you have another parameter as max depth, right? You have max depth also. Then you have mm, minimum sample splits, minimum sample split. What more parameters do you have? Minimum samples, I think leaf, minimum samples leaf, minimum samples leaf. And one you have boots strap. Okay, now give the range from for each the parameter. N estimator, we are giving range random integer from 100 to 500. It will automatically select from 100 to 500. For max depth, we are giving it random integer 10 to 50. For this, we are giving it random integer 2 to 10. For max leave, we are giving it random integer 1 to 5. For bootstrap, we will be giving it two option because bootstrap is either true or false. either true or either false. So here are our parameter distribution. Let's run it. Automatically get run. Successfully gets run. Now let's initialize our randomized search CV. We will initialize it in a variable called random search equal to randomized search. Okay, randomized search CV. Now inside randomized search CV, you have to first you have the parameter estimator. In estimator, you will give your model. Your model is what? RF. You will give RF. Then you have parameter distribution. Params distribution. In this, you will give this your dictionary in which you have defined parameters. So we will give params dist. Okay. Then you will give number of iterations. How many number of iteration do you want? I want a fast run. That's why I'm giving 5 only. Then you have how many times you want the cross validation. I am giving it, you can't give it 1, you have to give it greater than 2. So I am giving it 5. That's the default limit also. Then there is verbose equal to 2. You can set it as 1. Then random state equal to 42. And on the basis of what you want to do this randomized search CV. So scoring equal to accuracy. Okay, just initialized, run it. Now fit your random search into your training data. Randomized search fit X train comma Y train. Run it. It will start your training of the randomized search CV. So after 5 minutes of training, our model is finally trained. Let's check the best parameters, our best parameters. So random search dot best params. So these are our best parameters. Now what we're going to do is we will store our best model. So we will make a variable best RF model and we will store it using random search dot best estimator. Best estimator basically gives you the model with these parameters. So now our best model is inside this variable best RF model. Okay. Now we will predict on X test using our best RF model. So do ypred equal to best RF model dot predict on X test. It has done its prediction. Now let's do accuracy, now precision, recall, and all the things. I'm just gonna copy the code from above. Mm, just copy this code and come below and paste. Just remove these spaces. Just remove these spaces. Okay, just run it. Let's check our accuracy. Accuracy is 88. There is a slight bit decrease. First it was 89. Then check precision. It's also 88 decreased. Recall 89. Good. F1. It's also 89. So good. Although our accuracy is not increased, but because I have trained for very less iterations. Okay, I have trained for very less iteration. You can increase this number of iteration you can do 20, 50. So there might be an increase in your accuracy. But basically I was showing the process of hyperparameter tuning here. Okay. Now let's save this model. What you will do is save this model. For saving the model, we will use joblib library that is by default installed with Python. So you just have to import joblib, run. Then you will do joblib dot dump. In the first parameter, you will specify which model you want to save. Our model is best RF model. Then you will specify the path where you want to save. I want to save random forest dot extension will be dot pkl pickle file. You will see a random forest dot pkl gets stored under your notebook directory, right? Now you want to load this model. How you will load? You will load it using joblib dot load and give the path. Our path is random forest dot pkl, and you will store it under loaded model. So now this random forest dot pkl have been loaded into this variable loaded model. We can do prediction also. For prediction, what we're gonna do is just take the x train 0 1. Okay, so we have data in this format. We will pass input also in this format only. For this, we will give new data equal to numpy dot array. You will pass 190 and then 1. Just copy, it, paste it here, just give a comma in between each of them. We are checking whether our model is predicting or not. Okay, run this. Now just predict loaded model dot predict. What we will predict? New data that we specified here, and we will store the prediction in a variable predictions. Okay, we got the error. Reshape your array using. Okay, we gonna do is array reshape 1 comma minus 1 dot reshape 1 comma minus 1. Let's run it again. Now it's successfully run. Let's check the prediction. We got 1. Like it will not, the hotel reservation will not get cancelled. I think 1 specified that only, right? Okay, so our model is doing prediction pretty much good. So this was all about Jupyter Notebook testing.